It's said that if you hug a chemist, expect a reaction. But how do reactions take place? Roll that graphic. Hi, I'm Paul, this is Science That Sticks. I'm going to do a brief little video here on collision theory. In other words, how a reaction actually takes place. Well, the thing about reactions, chemical reactions that is that it's really fundamental to understand. Particles, molecules, can collide with one another, bump into one another, with sufficient energy that bonds that hold the atoms together break and new bonds are formed. That's pretty much it. Let's draw a picture of that behind me. So here I've got some particles. To give them a bit of definition, I'm going to colour some of them in. Okay, so these are one type of particle and these are another. Now, if they don't have enough energy, in other words, sufficient energy, the bonds can't break. In other words, whatever's joining the particles together, they can't be separated very easily. But if they have enough energy, when they collide with one another, then a brand new molecule can be formed. So we could find ourselves with this, for example. Now, here, this could represent the reaction of hydrogen and oxygen to produce water. Now, obviously, it's not balanced because I've got one molecule of O2 and I've got two of these, but it doesn't really balance. But it doesn't matter at this point about it balancing. What's the key point? The key point is that this oxygen atom is held together by chemical bonds. These hydrogen atoms are held together by their chemical covalent bonds. And with enough energy, all the bonds that are involved can be broken and new bonds can be formed in the form of a new product. This is a new chemical species. That's oxygen, the element, that's hydrogen, the element, and it's pretty easy to really grasp that. Now, this is how a basic reaction takes place, and we can calculate the rate of the reaction, in other words, how fast it is, if we use a stop clock. In this instance, it's instantaneous because this happens to be an explosive reaction, so the rate of reaction is very quick. There are lots of things that affect the rate of reaction, and I'll go into those in another video. So, what's the takeout from this? Well, a chemical reaction is when bonds are broken and new bonds are formed. They collide with sufficient energy so that the bonds can be broken and that new bonds can be formed. There's nothing difficult in that. Now, the faster the particles, the more chance there is that there will be a successful collision. The slower the particles' movement, the lower the chance or the lower the probability. This is all very easy stuff, but how do you speed something up? When you give it more energy. How do you do that? You heat it up. Well, what if you can't heat it up? Well, you can introduce more particles. If you've got more particles, you've got more chance of a successful collision. That idea of introducing more particles means that you can increase either the pressure, in this case it would be the pressure because they're gas, or it could mean increase of the concentration. If it's a solid, you could do other things with it, and if it's a concentration, you could do different things with that as well. Now, that's pretty much it. Until next time, stay cool. Bye for now.